Nick. It's pretty interesting. So, one way of improving the accuracy, because one of the problems you're always gonna find, like you're always gonna see, is the fact that you tell it, oh, there are those like predefined things, and then a new class type appears, things not work very well. Maybe the difficulty, days of the week will not appear, but maybe the data will change, day of the week and so on. You see, it's not done very scalable, right? But it's gonna work for now. So we try to find the balance. What we could do, we could, instead of having like the rules and saying that you have to respond in this specific way, here you would put something a little bit more sophisticated. You would explain things like, what does difficulty beginner mean? How to classify someone is beginner, intermediate. You could make rules like, if someone worked out less than 5 years, consider him beginner, or less than 1 year, beginner, 1 to 5. You could explain those rules, but you're always going to run into the problems that rules will not be enough because the rules will not be verifiable very easily. The model is designed to predict the token. And the best way to predict the token is to go through a lot of data and load a lot of data into the context. Of course, you have to be careful not to load the garbage, but I want to do one experiment. I have to tell you, I haven't tested it in this project, but I'm having a good intuition about it because I've used it before. So we're moving a little bit towards RAG territory. The idea is, instead of providing all those things here and explaining what kind of data is possible, maybe we can show it a lot of examples. So let's try an experiment where I don't do this. I could even totally remove it, but let me show it maybe. And then I can say return only JSON with the following scheme. And of course I want to tell that not all of it. The result can be partial. I can say string or undefined. Actually, oops. Yeah. And now, instead of here making the very comprehensive set of rules, I can say, hey, load the context. And then we say, you have access to the following data, read it carefully, and use it to build query parameters. And here we go, we do the JSON thing. Yes, and then we maybe not say classes tab because that's a bit of a hacking. We would say classes here. And then we put it here. And then we want to give it some examples. You see, but when you give those examples, how do you even load it? Well, technically, it's not that difficult because we are here on the generate endpoint, and then you have the on filter, and then technically speaking, we already have it, right? It's a signal fitness classes, so why not to provide it? And let's see if this performs similarly. The downside of this approach is that I'm going to be sending more tokens, but since I'm on Ollama, that's not a big deal. All right, so let's just say, let's start with the basics. I like yoga a lot. Let's see if we're sending this. It's quite a lot, so pretty, yeah. I mean, you could filter it out, right? That's one way because we stuffing a lot of irrelevant. It's like a brute force, but you would be surprised how often brute force just works. Like sometimes you think like those systems should be like super intelligent, and it's true they are, but they've been like pre-training is one big brute force. Here you go, yoga. But I did return only one, so maybe I could like provide more information. So here we go. Day of the week, Monday. I didn't say anything about it. Instructor Sarah Chan, beginner. So I think what it did, it read all my examples and then it mapped that, oh, if I say anything about the yoga, and since Sarah Chen is the yoga instructor, I'll probably want to return only that. So we can work on the prompt more and provide some more explanation. And some ways of doing that is to change that a little bit, because by the maybe even that, because remember, LLMs read from top to bottom, and then it read all the data, so it's sort of like biased itself towards something. And now we just start creating those rules. And then I think it's worth to mention that for the model, but I love to lift weights. Let's see what it comes up with. And as you can see, it's much slower because of that. But I really hope we can tune it to be much better and much more accurate. Yeah, so it did the strength, but you see it, it did the null. So it did not follow. Obviously, I can filter that out on the back end, but I would say my model failed because he should never make null. And that's something that is not very well explained, but also you can see yourself like banging your head against the wall quite often with those models, because you will see, why did it do this way? And suddenly it will do the other way. And sometimes it's just because the context is so stuffed. So I did stuff a lot of things in the context to start with. But generally, you stuff so much that especially the small models, they start underperforming. And this could be a moment when we could introduce a better model, because remember, CodeGamma 70, pretty small model. I mean, it's a tiny model, right? We could play it with other models, or we could start adding those exceptions. I really think that adding an exception is good thing no matter which model we use. So I'm gonna do it. So here we say return only JSON object with the following schema. Keep in mind that you should map only the properties relevant to the user query. All right. And I would like to show you some more techniques. So one thing is we have this prompt all good, but we could also use something technique called meta prompting. For the meta prompting, I like to use the ask mode because I want to be more in control. I don't want it to start playing with my prompt without me knowing what's happening. So I would say, here is the prompt that I use. However, it produces negative results by not following the rule that it should respond in partial JSON. It fills things with null. Undefined would have been better, but ideally we would not have the property at all. Provide the feedback and potential improvements. Keep in mind that we are running it against small 7-bit models. I don't want to tell what exactly the model, because I don't know how Cursor will decide which model answers my query. There is a bias towards models in the same family. They will bias each other, which means they will favor each other, and I want to avoid that. The schema example, okay, good. Okay, there are some critical rules, so it did similar things, and then it provided an example. I want to keep example as the last resort of the situation. So let me copy that. Looks pretty similar. I did too much. All right. What is wrong? Yeah. Okay, and then I want to keep this for later. All right, let's see. What was my last query? I wanted to get the I like lift weights. All right, it's much better, right? I like to lift weights with, let's see if I have two trainers, James. Yeah, not very good. I like to, I love cardio. Let's see, I'm trying to find difficult, not difficult. Sarah? Mike, okay, good. David, all right. So I love cardio with Mike. Let's see if this works. I believe this was Mike, yeah. Yeah. So you see, it also, so it did the HITT and then instructor Mike Johnson. So it was actually smart enough because it looked in my data I've provided and then it normalized Mike into Mike Johnson to prevent all kinds of problems with my backend API. Mike would have worked pretty good, but it could probably figure it out that, oh, there is only one Mike called Mike Johnson. So I'm just gonna give you this result. So now what I want you to learn is that you see the idea is by providing this context from the beginning, you literally give examples for the model. Of course, you can overfit towards those examples, but it's not necessarily a bad thing because they are updated. These classes come from the initial call, which means it's always everything. And of course, you can filter it out, do all kinds of other stuff. That's not the purpose of this introductory video. I just wanted to show you like the basics of prompting and some of the techniques. Now, the next thing that normally you would see in this situation is that the model will start maybe not hallucinating, but it will start missing some of the important things. So those rules will become quite important. You have to be very like wary about it, especially each time you add an available property, but also providing the examples start to become pretty important topic because people will ask all kinds of weird stuff here. Um, and then uh, I'm just thinking about something else. I'll get back to it. But the idea is that people will write weird things, and therefore you will need to log those queries and then see where the model fails. And then whenever it fails, you will literally have to provide it as example. Very often you will use examples for the positive, which is pretty obvious, but also for the negative ones. So when user asks about, so actually, I'm a girl and I want to work out anything, but it has to be a female instructor. For whatever reason, girls like to work out with female instructors. Let's see if the model generalized it. You see, no, it didn't. So now we would have to explain what the female is. So, I mean, obviously the model understands what's the female. It's just that we would have to make those rules for the weird queries, like, oh, maybe we could in our data provide the gender inside the data, right? Then that's gonna be much easier for the model to figure it out. But maybe if it's not there, things like geolocation, ranges, things like this, it's good to explain in some mathematical formula. And generally, like you want to explain the model. So this is a set that the user can actually ask. And when it does, you want to generalize it to this field. So you want to create this like meta mapping. But again, meta prompting is very useful in those situations. For example, now I would ask model why. So I can show you how it's done. So for example, I'm here and I say this is pretty good. However, the query produced this query params, which is wrong. Why so? What can I do to explain the model to generalize female names into this property without putting that into my context data model? Let's see what it says. But again, one way could be use smarter model. On the other way, it could be like, whatever. We just don't support those queries. It's a proof of concept. We already get something out in no time. And yeah, the product manager will be happy anyway. We could be providing like a template of what the model understands, what the model doesn't understand, show some examples, maybe navigate the user towards asking a specific questions. But the general idea is going to stay the same. The prompt structure will be like this. Okay, what does it say? Must be actual instructor name. No, okay, yeah. So it just says like, dude, like make sure. So we just start using heavier language to explain things, and that's like, sure. But as I mentioned, we could be providing those examples, and I think it's a good time to do it because, as I mentioned, it's sort of as an edge case in our system, but we can still try to provide it. So let's have a look. Obviously, those things can go pretty what's it called. It can grow as well, right? So very often you would resolve examples according to what the user actually asks. So we would have like predefined templates for those examples based on the query. And then you would use like embedding model to actually find those examples in your database that are relevant, that are similar to the query that the user asked. And then you can control the amount of examples here. That's the next level. But then we get very close to RAG systems. And this is what I didn't want to do. And then you see, model also provided a negative example. Maybe maybe not negative, but like edge case for like something that was not explained. Okay, and then let's see. You could also frame it differently. You could say, instructor that is a female. Maybe that was, let's have a look. Let's see if the model can generate this. But yeah, now when I think about it, it's going to be quite complicated because the instructor expects a specific instructor name. And you see, it just shows Sarah in yoga. maybe not the best. So there is some fine tuning that we can do. But as I mentioned, I would already consider that pretty an edge case situation because the word female does not appear in our data set and it does not, it's not, it can't be searched for. So technically speaking, you could put like filters of what the user can really ask. Or one of the easiest thing is to add the property in the data that the specific instructor is a female or not. That would already support. And then without changing a lot in a prompt, you actually start supporting it. So the prompt is flexible to your future cases. So that's pretty good. Yeah, the only thing is this part is slightly, you see, it's slightly model specific. But again, I mean, or you want freedom and return a lot of stuff, or you want more narrow cases, and then you have to provide it. So yeah, I hope you learned something. That was it, more or less, about the prompt structure. This is just the basics. We're gonna talk about a lot more advanced stuff. But I hope it was entertaining. Leave me the comment. Let me know what you think.